Now, viewers, we welcome you to Home Class TV. I read myself, Alewi Tosin. This is electricity part 3. On this part 3, we are taking circuit. What is a circuit? A circuit is an enclosed path through which current flows. Last time we told you what current is. We said it is what? We said it is the flow of electrons in a circuit. Now, circuit, we said, is what? Is an enclosed path through which current flows. This is a typical diagram of a circuit. A circuit. Now, we have a circuit connection here. Here, we have this as the voltmeter. This is the voltmeter, which is an instrument used for measuring voltage. And we have this as a standard resistor. This resistor, which is, the voltmeter is always connected in parallel. The voltmeter is always connected in parallel. This is a parallel connection. When we get to parallel types of connection, we will explain more about that. Now we have this, the ammeter. The ammeter. The ammeter is connected in series with the cell. The ammeter is connected in series with the cell. This is symbol of a cell. The ammeter A measured in amperes, voltmeter measured in volts, and we have the what? The resistor, which measures resistance, is measured in what? In ohms. And here we have this as the plug key. That's the key, which helps to what? To control the flow of current in the circuit. We call it the key. That's the plug key. Or we call it a switch. Either of the two. We call it a switch or we call it the plug key. It helps us. It's just like the normal switch we have in our home, which ons and off the our power supply. Now, we have this as a variable resistor. Variable resistor. Variable resistor. Now, what's the difference between a resistor, a standard resistor, and a variable resistor? A standard resistor has a fixed ohms. It is a fixed resistor. You can have it as 1 ohm, 2 ohms, 3 ohms separately, like that. When you need 2 ohm resistance, you pick one of it. When you pick a 2 ohm resistance, when you need 4 ohm resistance, you pick what? You get a standard 4 ohm resistance. Resistors. But in case of variable resistor, it is a resistor that can be varied. It can be varied. It can be varied. Examples of a variable resistor is our resistance box. Our resistance box is an example of what variable resistor. We also have the rheostat. Rheostats. Those are examples of variable resistor. So variable resistors are resistors that are what? That can be changed, that can vary. While the standard resistors that are what? That are fixed. Now, let's take types of circuit. We have the open circuit, the closed circuit, and the short circuit. What is an open circuit? An open circuit refers to a circuit whose key is open. Whose key or gap is what? Open. We call this the gap, which is also what? The key. When it is open, like this now is an open what? Circuit. When it is open, which permits what? Free flow of current. We call that kind of circuit what? A open circuit. An open circuit. When we add the key open, we say it is a what? An open circuit. But for a closed circuit, this is a circuit whose key is closed. Whose key is closed. Whose key is closed. Let me correct the statement there. When the Circuit is when the circuit is open, it means there is no flow of current. It is stopped. But when it is closed, that means it is connected back. That means there is flow of current. Now, for this now, we have we call this closed circuit. We say it is when we have it when there is no gap, when the gap is closed. So we call it the circuit in which the key is closed. While a short circuit refers to a circuit which has no load on it. It has no load on it. No load on it. No load on it. No load on it. So it's a circuit which has no load on it. That is a closed a short circuit. So those are the three types of circuit. Now let's proceed. Now let's take Ohm's law. What does Ohm's law says? Ohm's law states that the current flowing through a metallic conductor is directly proportional to the potential difference across its end, provided all temperature and other physical quantities of the conductors remains constant. That's Ohm's law. The current flowing through a metallic conductor is directly proportional to the potential difference. We said our current is directly proportional to potential difference V, which means that we can say that our V is equals to Ki. Now from this now, where K is the constant, where K is constant, so our constant now is the resistance of the material. Where resistance R is is the constant here. Resistance R is constant. So we say that our V equals to Ri. And I like calling it V is equals to V is equals to Ri. And when our V is equals to Ri, if you divide both sides by I, so we can say that this cancels this, then we can say that our resistance is equals to V over I. Resistance is V over I. And so also if we divide through by R, we can say that our I is equals to V over R. These formulas are important. V is equals to Ri, R is equals to V over I, and also our I is equals to V over R. Where our V is the difference, our R is resistance, and our I is the electric current. Now, what is Ohm itself? Stating Ohm's law is different from defining Ohm. Ohm is a resistance of a conductor. When resistance of a conductor, when potential difference of 1 volt is applied and it causes 1 ampere of current to flow. It causes 1 ampere of current to flow through it. It causes 1 ampere of current to flow through it. So we say that Ohm is a resistance. As you all know, is a unit for measuring resistance of a conductor. When potential difference of 1 volt causes 1 ampere to flow through it. Now, so that is that for Ohm's law. Let's talk about some substance that all metallic substance obeys Ohm's law. Mostly all metallic substance obeys Ohm's law. But some substance does not obey Ohm's law. We call them the non-ohmic conductors. Non-ohmic conductors. One example of a non-ohmic conductor is gas. Rectifier. You have the rectifier. Is a non-ohmic conductor. We also have the diode. You have the diode, is a non-ohmic conductor. You have the transistors. Transistors is a non-ohmic conductor. So that is an example of non-ohmic conductor. So let's stop there. We meet next time. Thank you.